All right, so section 1.6 has solving like all kinds of different equations. That's what's called other types of equations. So to start with, we're going to solve polynomials, but there's like a whole chapter devoted to polynomials. So we're not going to solve difficult polynomials. We're only going to do polynomials that will factor. All right, so a polynomial equation is a result of setting two polynomials equal to each other. General form is when one side is 0. So if you get it equal to 0, which is the first step in solving, is to get it equal to 0. And then the degree is the highest exponent, but that's not really that important other than to know that if the degree is 4, then you should have 4 solutions. But sometimes you have imaginary solutions, and we're not going to be able to see those until we get into, I think it's chapter 3, where we talk about polynomials. Okay, so to solve a polynomial, simple polynomials, we are going to make sure that it's equal to 0, factor, set our factors equal to 0, just like solving by factoring with quadratics. So the first step here is to subtract the 12x squared so that our x's are all on the same side and we equal 0. That's a 12, not a 2. All right, so then we need to factor. I'm just rewriting this because it looked like an R when I tried to squeeze that one in there. All right, so we have a GCF here of 4x squared, which leaves me with x squared minus 3. So then we can set our factors equal to 0 and solve. So we would divide by 4, take the square root, and you get 0, but technically that happens twice. Here you're going to add 3, take the square root, and you get plus or minus the square root of 3. So it looks like we only have 3 solutions. Technically we have 4 because that 0 happened twice because of that x squared. But again, those are things we'll talk more about in chapter 3. Alright, so next problem. Again, we want everybody on the same side. So we're going to do 12x to the third plus 3x squared minus 8x minus 12 is equal to 0. Opposite of these guys to move them over here with everybody else. Alright, so then we have to factor. Well, we have 4 terms, so we should be able to factor by grouping. So we're going to pull out a 2x squared. You can't take out a 2. We're just going to take out x squared, which leaves us with 2x plus 3. For these two terms, we can take out a negative 4. Negative because it's negative here. 4 because they're both divisible by 4. So this is going to leave me 2x. This is going to give me 3 above and on. So we have these matching parentheses that we can pull out as a GCF and then have this guy left. Now, if you were told to factor completely, there would be a step of factoring this, but we're solving, and we know how to solve this if we equal it to 0. So we can skip the factor some more part. All right, from here, I'm running out of room, so I'm going to subtract 3, divide by 2, and get negative 3 halves as that solution. Here, we're going to add 4 to the other side. Take the square root of both sides and get plus or minus 2. Take the square root and you get plus or minus 2. So there's positive 2, negative 2, and negative 3 halves. Those are 3 solutions. All right. Next problem. This one's already equal to 0. So we just need to factor. It's 2 terms. I believe we have a GCF of 3x. Alright, so if I divide that 3x off, I have 4x squared minus 9 left. And then we're going to set those factors equal to 0. Again, this would have factored again, but it's not necessary. We can solve this. Alright, so here we divide by 3 and we get a solution of 0. Here we're going to add 9, divide by 4, and then take the square root. So remember, we can take the square root of the numerator and the denominator separately. We need plus or minus. The square root of minus 3, the square root of 4 is 2. So we got positive 3 halves, negative 3 halves, and 0. All right, so next we have the 3 terms. So we're going to guess and check. To get x to the 4th, we need x squared, and that's going to work out to get us our middle terms. To get a positive 3, we need negative 1, negative 3. Now we're multiplying to get this, adding to get this. So we need 2 signs that match to get a positive when we multiply, and they got to be negative if you want to get a negative when you add. All right, so x squared minus 1 is 0, x squared minus 3 is 0. All right, on this one, we're going to add 1, take the square root of both sides, and get plus or minus 1. Here, we're going to add the 3, take the square root of both sides, and get plus or minus the square root of 3. So we have positive root 3, negative root 3, positive 1, and negative 1. All right, so that's solving a polynomial. At this point, we're just going to do the ones that factor. All right, so pause the video, try these, and then we'll see how you do. All right, so first we need everybody on the same side. We can take out a 3x squared, which will leave us an x squared minus 16. So 3x squared is 0. So x squared is 0. So x is 0. Take the square root. Alright, x squared minus 16 is 0. So x squared is 16. So x is plus or minus 4 because we took the square root. So positive 4, negative 4, 0, which is a repeated solution. Alright, number 2. 3 terms means we're going to guess and check. We need x squared, negative 7, positive 1 will give me negative 7 when I multiply, and negative 6 when I add. We're going to do x squared minus 7 equals 0. Add the 7, take the square root, and x is positive or negative root 7. Alright, so the other one, x squared plus 1, is 0. Subtract the 1, take the square root of both sides. The square root of 1 is 1, but it's negative, so we need an I, and you need plus or minus because you took the square root. Alright, so that's solving polynomials. Next, we have radical equations. So if you need to write some steps down, you can write these steps down. Basically, with radical equations, you want to try, if you only have one radical, to get it by itself and then square it so that the radical goes away. Generally, you're going to end up with a quadratic at that point. Not always, but sometimes you do. If you have radicals on both sides, then you're just going to have to square them as they are, and it causes more work. And usually, you're going to have to do another step of getting rid of radicals. There won't be any like that on your test. There might be one in your assignment. Alright, so extraneous solutions. We talked about excluded values when we did rationals, which is kind of the same thing as an extraneous solution. It's a solution that you get that doesn't actually work because it causes an issue. So in rationals, it was dividing by 0. With radicals, it's a negative under an even root. So all I need you to understand is that when you're solving something with square roots or fourth roots or sixth roots and even root, you need to make sure that you at least mentally check your answer and make sure that it's not going to make you take the square root of a negative somewhere. Because if it does, then you have to throw that away. It's an extraneous solution, like an extra solution. Okay, so we want to get the radical by itself. So we're going to subtract this 3. So we have square root of x plus 3 is equal to x minus 3. Alright, well then we want to square here so that we just have plain old x plus 3. Well, if we square one side of the problem, we have to square the other side. Remember that you're squaring the whole thing like as a binomial. So you're going to get x squared, and then delete that in blue. You're going to get x squared minus 3x, so minus 6x and plus 9. Alright, then we need, it's a quadratic, so we're going to hope that it will factor. Probably about 95% of the time they will. Occasionally there's one that won't factor. So I'm going to subtract x and subtract 3 so that I'm equal to 0. And then we're going to factor this quadratic. So let's see, x and x, negative 6, negative 1. Alright, so then you can put those equal to 0 and get 6 and 1 as solutions. Alright, but you have a square root in the original problem, so you've got to go back and make sure they're okay. So 6 plus 3 is 9, the square root of 9 is 3, plus 3 is 6, which equals 6. Alright, so making sure that you follow. We did this, and we said that it checks out, so this answer works. Alright, so now mentally again, or you can write it out on your paper, whichever. For 1, we want to say that 1 plus 3, take the square root, plus 3 gives me 1. Well, 1 plus 3 is 4. The square root of 4 is 2. 2 plus 3 is definitely not 1. This is not going to work. So D is garbage. 6 is the only answer. Alright, so next problem. We already have a radical by itself, so we want to square here so x comes out. Remember, we got to square the other side. So we're going to do x squared. Then we do x times negative 6 twice, so negative 12x. And then 6 times 6 is 36. Alright, again, it creates a quadratic most of the time. So we need to move this x over here so that we have 0. So if we subtract another x here, that's negative 13x. Again, quadratic formula will always work, but this section in the book tends to give you quadratics that are going to factor. So I would say before I try the quadratic formula, I would think about if I could factor it or not. And I think here we can do negative 9, negative 4, which will work out. So make that equal 0, make that equal 0. And we get 9 and 4. Alright, there are some occasions where you can have two answers with the square root function, but not many. So usually if you get two answers, one of them is going to have to be thrown out. So we've got to go back and see which one. So here, if we plug in a 9 to the original problem, you're saying that 3 is equal to 3. Yes. But if we plug in a 4, you are saying that 2 is equal to negative 2, because we assume principal values, and that one is garbage, so throw that one away. Alright, so here's the U try for this. Okay, so your first step is move the 2. The second step is square both sides. So x plus 18 falls out. This is going to be x squared minus 4x plus 4. Do everything on the same side. So subtract x, subtract 18. So subtract x gives me negative 5x. Subtract 18 gives me negative 14. I think we can go with negative 7, positive 2. So we get x is 7 and x is negative 2. So let's see if those work. 7, we're going to do 7 plus 18. And then plus 2 is equal to 7. So 7 plus 18 is 16. No, that's really bad math. No, that's right. It's 25. Whoa. I knew it ended in 5 and my brain was saying 16 because I wanted it to be a perfect square. I have no idea what I was thinking, so just ignore all of that. 7 plus 18 is clearly 25. So the square root of that is 5. Plus 2 is 7. So this one checks out. If we tried a -2, then we would say -2 plus 18, which is 16. So we just say that 16 is 4. 4 plus 2 is going to have to give me -2, and it doesn't. So this answer is garbage. Alright. So that is solving when you have square roots. Alright. This screen is kind of overwhelming. This is what I need you to understand. This is important to write down. I'm trying to draw and it's not helpful. Alright, we have radical. What does that say, radical? Oh, I got you, sorry. Radical equations when they give you fraction exponents. Because remember, fraction exponents is just a radical. So, if they give you something with fraction exponents, then you are going to isolate the expression that has that rational exponent, that fraction exponent, raise both sides to the reciprocal power, because reciprocals, when you multiply, cancel each other out and just have one. So what this other part is saying is that if it's even, if m is even, so this numerator, if that guy is even, when you multiply it here, he becomes the root or the index. So that means you got to put a plus or minus because you're taking a square root or a fourth root. Okay? If we have odd as this guy, which becomes the denominator when we raise it to that power, then we don't need the plus or minus because odd roots don't need plus or minuses because they can have, they only have one answer. Alright, so then step 3 is to check. You only really need to check if it's even. So in this case, we're going to check. In the case of it being an odd index, we don't have to check. I'm sure that that's really fuzzy right now. Let's try some because it's not that bad. These aren't even really like solving. We're just going to skip this one. Let's just solve. Okay. So, just like my PowerPoint, sometimes I make them and sometimes they come from a teacher at BIPSI. And sometimes I forget that there's random slides in there that I would rather just skip. Okay, because we're going to handle what's on that slide as we solve, and I think you'll be fine. If you're not, then let me know and I can work the problems that were on that slide if you think you need them. Okay, so we need to isolate the variable. So we're going to add 25. Divide by 5. Alright, so now comes the part where I've got to get rid of that exponent. Well, if I could just multiply this guy by 2/3, then it would go away and I would just have x. Alright, well, if I want to multiply this by 2/3, I have to raise that side to that power, because a power raised to a power is when we multiply exponents. So I'm going to have to raise the other side of the equation to that power as well. Alright, so what I skipped on that last slide is how to work a problem like this. Alright, so when you have this, there is a property that says a to the m over n is equal to the nth root of a to the n. So we just rewrite this as the cube root of 5 squared. Alright, so you can do that, but that doesn't really give me a better answer. We could clean it up if 5 was a pretty number, but it's not. So in your calculator, you can just do 5 raised to the, and then do 2/3 as the exponent. Now, I know you don't have a graphing calculator at home, but if you will just turn your cell phone sideways when the calculator is open, you will get an exponent option. It's like x to the y or y to the x, I can't remember. So if you'll type in 5, then hit the button, I think looks like this on your cell phone, and then type this in as the 2 divided by 3 in parentheses, it will give you this answer. You also have, there's a graphing calculator app that you can download called Calc84 or Calculate84, depending on which kind of phone you have. It's free and it's the exact same calculator that we use in class. Okay, so if you're looking for ACT multiple choice answers, they may read it like this, they may write it like this, and they may give you a decimal. All three of these are valid answers for X. Because this ended up being an odd root, we don't put plus or minus. So we are done here. All right, I'm going to erase this out of the way. All right, next example. We need to move the 8 to the other side. Then to get rid of that exponent, we're going to raise to the reciprocal power. So we just have X here. And then here, if we think of this as the square root of 4 to the third, then it's really just 2 to the third, which is 8. But again, if you type it in your calculator exactly like this, it will give you 8. Now, when we did this, we inserted a square root. So as soon as we insert a square root, we have to put plus or minus on our answer. So we can have positive 8 or negative 8. We also have to think about what happens if we plug those back in. Okay, so always stop and think about plugging them back in. So let me go back to A because I really didn't try that one. If I plug that in my calculator, it's 5 times 5 to the 2/3 power minus 25. Do I get 0? That's supposed to be the 3/2 power, right? I cannot function today. Alright, so let me double check because I'm not getting, we said X would be 5 to the 2/3 to the 3/2, which is just 5. Times 5 is 25. 25 minus 25 is 0. So that one checks out. The next one, if we plug in a positive 8, 8 to the 2/3 power is 4. 4 minus 8 is negative 4. If we plug in a negative 8, negative 8 to the 2/3 power is positive 4. Minus 8 is negative 4. So those of them work. Alright, so for the next one, we need to raise this to the 3/2. So we're going to raise this side to the 3/2. Our X minus 4 comes out. 16 to the 3/2. So in my calculator, I'm doing 16 to the 3/2 power, and I get 64. Then we add 4, and we have 60. Alright, but we made it a square root, so we've got to do plus or minus 64. So when I add 4 to positive, oh, mercy, back up. I got 60, and that's clearly not right. Okay, we have to do plus or minus. We're going to add 4. So we do positive 64 plus 4, and we get 68. Or we can do negative 64 plus 4, which is negative 60. We have these two answers. You plug them in. 68 minus 4 is 64. To the 2/3 is 16. So that one checks out. We plug in a negative 60. Negative 60 minus 4 is negative 64. Raise that to the 3/2, and you get that it is an error. So this one does not work. Alright. So for absolute absolute value. Remember, absolute value is the distance from 0 and the number line. You have an absolute value equation. It's just when there's absolute value in the equation. We have to rewrite an absolute value equation without the bars in order to solve. So if you think about this statement, I can write it like either one of these, because if this was, like let's say that we want absolute value of x to be 30. So if I'm talking about the distance from 0, I could be at positive 30 and my distance from 0 is 30, or I could be at negative 30 and my distance from 0 is 30. So this has two possibilities. Okay, so you just have to keep that in mind. So to solve an absolute value equation, you're just going to write it equal to the positive and equal to the negative. This right here has no solution, because remember, absolute value means distance from 0. And the distance from 0 cannot be negative, because you can't travel a negative number of miles or inches or whatever. Alright, so for this one, you're going to take what's in the absolute value, equal it to 5. Take what's in the absolute value and say that it could have been negative 5, and then when I did the absolute value, I still got positive 5. So add 1, divide by 2. Here you're going to add 1, divide by 2. And we get two answers, 3 and the negative 2. Alright, so next, we need absolute value by itself before we can make two problems. So we're going to add the 20. Then we're going to divide by 4. You cannot distribute into absolute value bars. Once you have those bars by themselves, then you can make your two problems. Common mistake is people will change this sign. It has to be the equal to thing that changes on that second problem. Alright, so we're going to subtract 1 and get 4. Divide by negative 2 and get negative 2. We're going to subtract 1, get negative 6, divide by negative 2, and get 30. With absolute value, there's no reason to check your answers, because absolute value should usually have two answers, because if you remember graphing those before, they make a V, which means they could cross the x-axis in two places. So having two answers makes sense, and there's nothing that can't be put into an absolute value problem. Alright, so try these. Alright, so we're going to move the 5 and get 8. We're going to make two problems. And we're going to get a 7 and a negative 9. Alright, over here, first of all, you're going to divide by negative 3, which in this case is going to give me 2. If this was not negative, when you divided by the negative 3, you would have gotten a negative 2, which would have meant no solution, because you would have absolute value equal to a negative. So anytime as you're working, if you have the absolute value by itself equals a negative, you stop and say no solution. Alright, but finishing this one out, you can have this as 2, or you can have that junk inside was negative 2. So we get 1/2. Subtract 2, subtract 1 from 2, get 1, divide by 2, you get 1/2. Subtract 1 from negative 2, you get negative 3, divide by 2, you get negative 3/2. Alright, I think that is all. Yes. Alright, if you have questions, please let me know. Try your assignment. If you run into trouble, send me an email, and I will do my best to answer your questions.